Well, I know how your eyes feel. All right. Here we go. Okay. So where all of this goes now is we're going to learn how we can use what Mendel discovered to make predictions. All right, we can make predictions or to analyze cross. So we use a graphic organizer called a Punnett Square. I've never actually bothered to look into this, but I'm assuming it's named after somebody named Punnett. Let's call him Jimmy Punnett. Big Jimmy P.
What one's this?
This is 3.5a, I think.
Okay.
3.5a. Okay. So Mendel discovers that the only way to explain what he sees with his pea plants, which is this weird thing where a trait almost seems to skip a generation. By the way, you've probably heard people say that about, have you ever heard people say that before about traits? They're like, oh, it skips a generation.
I am living proof.
Yeah?
On my mom's side, my great grandma's crafty, my grandma's crafty, my mom's not, and then I am.
See, there you go. So who knows? Maybe that's some recessive trait in there. But that's exactly the thing. When we talk about things skipping a generation, we mean that you can see lots of things like Mendel saw there, where you can have a short plant produce only tall offspring, but then all of a sudden the grandkids, all of a sudden that shortness reappears, right? That's what Mendel saw. And he said the only way you can explain that is if we are getting one copy of a gene from mom, one copy of a gene from dad, and it turns out that when you have two copies, one of those copies can be stronger than the other one. And he called that the dominant trait. And if it's not stronger, he said we call that the recessive trait. Good. And then he said maybe you have two copies the same, in which case we say you're homozygous, or maybe you have different copies, in which case we'd say you're heterozygous. All right. In humans, there is actually a single gene that leads to two really distinct, different things. Now listen, there's a lot of genes that control the way your face looks, but there is this fundamental difference between what we call sort of a round face and an angular face. And do you know what I'm talking about? You know, some people, like, they just seem to have, like, straight line features. Like, you look at their face, and it just seems like you could draw, if you were drawing it in a comic book, you'd use a ruler. You know what I'm talking about? Like the Superman jaw. Yeah. And then some people, like me, there's a lot more cheek going on, and it's just there's a round thing happening there. You know what I'm talking about? Yeah. It turns out part of what controls that is a single gene. There's more to it than just the one gene, but for simplicity, to just kind of make it basic, we're going to say that there's a gene that controls that. And it's got two alleles. Now, just looking at this, they've decided to call the alleles round, big R, and angular, little r. Just looking at how we've named that, what do you think you could tell me? A round face we show with a big R, and an angular face we show with a little r. What could we conclude from that, knowing what we know about what geneticists, what genetic scientists do and how they name things? Which of these traits do we think, yeah? You're doing great.
The round one is the dominant.
Very good. See,
there we go.
That's great.
I did it.
Beautiful work. Good. Yeah. Because we know that more often than not, scientists like to use the uppercase to show the dominant trait. The fact that the uppercase R for round means that round is a dominant trait. And it means that angular then is the recessive trait. Cool. So with that in mind, I want you to take a minute and fill this out. What would be the phenotype, the genotype, and what would be the phenotype for each of these? Boy, take a minute, you can talk to each other, but if I was homozygous with the dominant gene, tell me what that looks like, both in terms of what genes I have and what my face looks like. You know, this is going to be some combination of R's, not this many, just two of them. And this is going to be like face is, and then you'd either be like round, or straight, or like Superman or what. So fill this in for me. Do your best. Listen, there's a lot of words here. A lot of big, stupid, sciencey words. So if you get a little confused, that's okay. We'll take it up. But take 2 minutes, see if you can fill that out.
Sounds like a horse.
I know. Listen, I'm so excited to be teaching. Oh, you have no idea. It feels like I'm doing my job again. I'm not just filling out a bunch of stupid worksheets on the internet. Ugh. Ugh. How are they doing out there?
Sounds like they're propping these chairs up there. Coffee time!
It is coffee time. When we live in a post-COVID world again, I can set back up my coffee and snack station back there. See, I always keep snacks back there, and I have stuff for coffee and tea and hot chocolate.
Ew,
And like people have mugs back there.
Go away.
I know, and so it makes me sad to not have my coffee and snack station set up. So one day we'll be back.
I have this class again anyway.
You're stuck with me, kid. No escape. All right, so talk to me. In this case, when we're talking round face and angular face, if I was homozygous dominant, what would that mean?
2 cats.
Sorry?
2 cats. 2 capitals.
Yeah, very good. So that'd be capital R, capital R. Homozygous means both my copies are the same, and dominant means that not only are the same, but it's the dominant copy I have. And so what's my face going to look like? Round is correct. Or in COVID times, mask. Everyone's phenotype now is mask. Yeah, you're right. It'd be a round face. Good. Okay, what if I was heterozygous? What would my genotype be then?
Little R and a big R.
Yeah, it could be that, or of course it could be...
Big R and little R.
That's right. You know, so it doesn't matter whether mom gives me the big R or the little r, whether dad gives me the big R or the little r. It means I have one of each. What's my face look like then?
Round.
Very good. Because even though I have one gene that says, hey, be round, another one that says, hey, be angular, which one of those is the dominant trait? Round. So the dominant one wins. And then if I were homozygous but recessive, what would my genotype be?
Lowercase r.
Very good. And in that case, my phenotype would be angular. I'd have that like Superman square jawline. You'd be like, wow, that guy's face. Or you know, some people, the square jawline, or even some people have like, it's almost like a triangle. Like they got like that super pointy chin.
Yeah.
Angular. That's an angular face. Cool. All right. Good job with that. Now, what would happen if this guy, homozygous dominant, was to mate with one of these guys? And we'll say this one. Doesn't matter which one, we're going to pick that one. What would the offspring look like? Well, there's a lot to unpack here, right? We haven't done one of these yet. This is a homozygous dominant, so this is a purebred breeding with somebody who's heterozygous, yeah. Ooh, well, we'll find out. You're totally right, but whoa!
What are they doing?
Wow. I like to think that they are doing cannonballs without a pool. You know, like just jumping and landing on the ground. Good Lord. Are they in the ductwork? Are you invading us?
You want to go like see what?
Are we all of a sudden, like, we're going to be teaching and all of a sudden that vent right there is going to pop off and people are just like in black jumpsuits going to jump in and they're going to capture my classroom. And I'm assuming they'll be ninja stars. And I'm excited about that. Even if they're used against me, I'm just excited. If you got to go out in this world, I think by ninja star is not a bad way. You know, that's all I'm saying. I'm just saying when it's my time, if it's a ninja star that ends it all, I'm okay with that. I can live with that. Okay, so we're going to cross these. And, okay, just to remind me then, if we have a homozygous dominant parent, then that genotype would be big R, right? That's what homozygous dominant means. We'll call that the first parent. It doesn't really matter. Maybe that's mom. And the second parent is the heterozygous one. And again, it does not matter whether it's big R, or little r, big, you know. It doesn't matter which of the two heterozygous ones it is. It'll give us the same result. The order here doesn't really matter. Usually, if it's one of each, we usually do the capital first and the lowercase second, but that's not a rule. That's just kind of how it usually gets done. Does that make sense? Doesn't really matter. You'll get the same answer. So how do we track this? Well, you could just work it out. You could draw pictures. You know, remember in the last lesson how I drew the little circles and we said big S and little s and we paired them off? You could do that. But here, we're going to borrow a trick from math. Did any of you ever learn factoring or expanding in math where we did like this whole thing and we said, well, we have x here and x there and plus 2 here and plus 4 there, and x times x is x squared, x times 2 is 2x, x times 4 is 4x, 2 times 4 is 8, all that crap? Yes. Okay, don't worry, we're not doing that. Not doing that. But we're going to borrow the idea of that grid work. All right? Sometimes when we want to cross things, when we want to multiply things, using a grid like that is a good way to do it. So we're going to do that, but no numbers, nothing like that. We're going to use what's called a Punnett Square. And what we usually do on a Punnett Square is we put the maternal genes here, i.e. mom, and we put the paternal, i.e. dad, down here. I don't really like putting dad because like biological father and dad are really two different things, but you get the idea. I like you can be some dad and not be the biological father, but whatever, just for short term. And we're going to put nothing here, okay? So if you're mom, in this case, all of your cells have a big R and a big R. But when you go through meiosis, when you make sex cells, all right, in the case of a female, egg cells, do your egg cells have 2 copies of every gene? See, sex cells are meant to be half of a new organism, right? So you don't give 2 copies of your genes, you only give 1. And if you go back to the meiosis lesson, you'll learn that it's random, whether you give them this one or whether you give them that one. It's random which chromosome they get. So half of the time, your sex cells will get this big R here, and the other half of the time, they'll get that big R there. Now, as it happens, these are the same copies, so it doesn't make a difference. But what you're putting up here is the possible sex cells. And mom's egg cells are either going to have this gene, or they're going to have, this gene. And again, in the case of mom, those are identical, so it doesn't really matter, right? But in the case of dad here, it might have this gene. So a sperm cell produced by this father might have the big R, but it also might have the little r. Does that make sense? So what we're putting here is the possible sex cells. Does that make sense? Now, when they procreate, if an egg with this big R is fertilized by a sperm with that big R, then the offspring, the child produced, will have what genotype? What will go here? Yeah, dominant. If this egg cell is fertilized by this sperm cell, what will this offspring be? Big R and big R. If this egg cell is fertilized by this sperm cell, what will go here? Very good. And if this egg cell is fertilized by that sperm cell, what will go here?
Same thing.
Very good. So let me ask you then, those are the genotypes. Let's talk phenotype. What will this offspring look like? Round-faced or angular-faced?
one?
Yeah, this guy here will be round-faced. What about this fella?
Round.
Very good. And this one? Round. And this one? Round. So, a homozygous dominant and a heterozygous parent, can they get any child who will have an angular face? No. No matter what combination you get, will be there. Does that make sense? There's an extra row in this column. I don't know why. So, we filled this in above. Like I'm writing this back down, but this is information we already had, right? These are the genotypes we could have, right? Like I'm literally just copying that from this table here. Is that comfortable? I'm not going too fast? All right. So, out of the 4 possible combinations, how many of the 4 possible outcomes are big R, big R? Let's look. Big R, big R. So 2 out of 4. What's that as a percentage? 2 out of 4 is? Yeah, very good. All right. What percentage are heterozygous? Big R, little r? Yeah.
I was distracted, but I can't go to the bathroom.
Of course. And you don't have to ask. And what percentage are little r of this? C'est impossible pour cette combinaison, n'est-ce pas? Ah oui.
What?
Donc il y a 0 de 4. Et 0 de 4 est 0%, n'est-ce pas? Oh, see, I can teach in French. I can teach in French. Look at that.
I almost failed my French.
Yeah, I unfortunately am not very good at French. I wish I were. I wish. It's my one big school regret. I wish I'd taken French more seriously. And I took it all the way through. I took it all the way through to grade 13.
I'm just no good at it.
Yeah, languages I feel like don't come easily to me, but I also feel like I could have worked harder.
Some
I didn't work that hard.
easier for me, some are not.
Yeah.
Where's me know that some people call it grade 13?
Well, I had grade 13. I'm old.
Back in the day.
Well, isn't it called
It was called OAC. No. When I went to high school, there was like an official 13th grade. Because, yeah, I'm old. So it was called OACs by the time I was there. I don't even know what those letters stand for. But I was the second to last year of it. So like the year after me was the last year that had it. And universities used to require it. So if you wanted to go to like a university program, you had to have your grade 13. You had to have 6 grade 13 credits. But then colleges didn't require it. And then universities stopped requiring it, so then they stopped offering it. So now you can take like a 12B, but like there's no such thing as a 12B course, right? Like you just come back and take whatever you want, right? But when I was in high school, there were OAC credits, and they were grade 13 credits. So we were like a whole year older than you guys when we were done high school, which is weird. So you guys, it always seems so young to me when we like send high school grads off now to like college, university, and trade school and stuff. It's like you're just like little kids. Sorry?
We're almost that old.
Yeah, and you know, like I honestly think like that line between like young adult and adult, who knows when you make the transition? I think it's different for every person. You know, some people are born older.
how old am I going to be?
You know, and like I feel like some people graduate high school and they're definitely ready for the next thing. I think some people definitely like a 12B would benefit them, or a year working or whatever. Everyone's different. Are you? Yeah, and I don't think it's a bad idea. I really don't. I think
Both my parents did it.
yeah. And I just think that sometimes like it's awfully it's just young to be like, hey, you're 17 and now you're going to go off to like college somewhere else, maybe like live on your own, or you're going to go to university and live on your own, and maybe you're not mature enough yet, you know, like I don't know. And the worst thing you can do, this is something I really believe, do a victory lap, like take a year off, work, whatever. For God's sake, the people who like rush into college or university and aren't ready and just spend the year like drinking their faces off and failing all their courses, It's like there's a lot of cheaper ways to spend a year drinking and accomplishing nothing than spending $7,000 to go to school and having it land on your permanent record. You know what I mean? Like if you need a year to get mature, take your year to get mature. And then some people are ready. Some people graduate and they're like, yeah, you can just tell. They're good and ready to go and they're off. Yeah. And the point is, you got to know yourself, right? You got to know yourself. Does this make sense? This is straightforward stuff, right? So this thing here, the Punnett Square, is as easy as you take one of each copy and fill it in the top, one of each copy and put it in the side, and then you combine them and it shows the different way they combine. And this means that if this mother and this father were to procreate, out of every 4 one of their offsprings, on average, 2 would look like this and 2 would look like that. Now, it doesn't mean they have to have 4 offspring. They could have 1, in which case there'd be a 25% chance you'd get this, 25% chance that, 25, 25. They could have 1,000 offsprings. Not if they're human, that's not possible. But if you were a fish, 1,000 offspring would be nothing. That's just like one cycle. You lay your eggs and there's thousands of them, right? Different animals do different numbers of children, right? Like a dog has, what did we decide last time I asked you guys? What did we decide, like 4 to 6? Was that the number we came up with?
Yeah.
Yeah, whereas a turtle might lay 80 eggs. Fish, thousands of eggs. Spiders, no eggs, right? Because we don't talk about spiders. Flies, tens of thousands of eggs. Also bad? Okay, we'll leave in sex alone. We'll leave in sex alone.
Oh my god, for some reason I thought it was okay to keep a fly as a pet when I was younger.
What?
Yeah.
They don't live very long, do they?
No, they don't.
Okay, so I want you to try this one. We'll take it up, and then I'll just really leave you to be on your own. But we will take this one up. So this is another trait that that Mendel looked at. Have you ever, normally when you buy, first of all, are you like me where when I was your age, I could not stand when my parents cooked peas, but they always seemed to?
Yeah, I'm not a big fan of peas.
Yeah. So, but normally you get a package of peas and they're all like really nice circles, right? Have you ever seen peas where they look like super wrinkly?
Yeah.
Yeah, that's a different type of pea. Yeah. And it turns out that's controlled by a gene. So you can have round seeds or wrinkled seeds. And round seeds is and wrinkled seeds is the recessive trait. Cool. With that in mind, I want you to go through this example here and see if you can work it out. All right? So take your time, go through this, and we will take it up in about, 10 minutes, maybe 15.
Figured out what the banging was, my friend told me.
Nice. Are they having a fight?
No, there was just a kid having a hard time.
Oh, poor guy. Sometimes we do that. Listen, if I weren't getting paid, I'd probably spend half my time throwing stuff around in here and, carrying on. But I think it'd be unbecoming of the teacher.
What are we doing?
The same thing we did with the yellow and
Yeah,
green.
do your best. Go through this. We're going to take it up, I promise. But we're doing great, let's try another one. Try some more? What's it say? Great, let's try some more. See, I try to be encouraging in my titles. That's good. When really, you're working from home. I don't know if you did great. Maybe you screwed it up completely, but see, it sounds positive. And I think that's important.
Orlando, I finished.
Oh.
I finished.
Excellent. Cool. So we'll take it up in just a couple minutes. But I'm going to give everyone a chance. And whilst I do that, I'm going to check and make sure that this laptop has been fixed and is now connecting to the internet.
Question.
Yes.
What's the F1 generation chart? What am I supposed to do with that?
The same thing.
So go up back to no, that's the one I missed it.
Oh, you missed it.
I'm leaving this. So that's gonna be.
There are apples.
All right, let's take a look. So, or do we need a few more minutes? I don't want to rush you. Sorry? Cool. Yeah, I'll take them. That's great. I will check my email.
Oh, hi guys.
Hello. Comment ça va?
C'est Sarah.
I'm sorry.
I have a question
No. I don't think we're done.
Microsoft friend.
When I was just a little boy. Come on, help me out here. I asked my mother, what will I be?
Will I be pretty? I don't know the words.
Will I be something? Here's what she said to me. Hey,
They're not even listening to us.
Sarah. Nobody's joining.
I
and this is really
prefer-
high for me.
I prefer that song over the bad 80s song. Sarah. No
That's
time.
Are there other Sarah songs? I can't think of one.
I don't know.
What's a Sarah song?
Sarah is good. Like, I like to serenade. Like, it's good for that. Like, there's a lot of Sarahs in other words.
Yeah. I'm trying to think, there's not a lot of Joe songs. There's like Cotton Eye Joe.
But there's a lot of Joe singers.
Yes, a lot of Joe singers.
I totally remember this.
Are you talking to me?
Oh, so what can I do for you? Sorry.
What did you say?
So I have a bunch of kids in my business class who are saving, trying to figure out how to save PowerPoint, like Microsoft program
Yep.
files, and handing them in on
Classroom.
Google Classroom, and they're having troubles. And I have
Okay,
one
so
way,
can
but
you-
I didn't know if you had a
Sure, yeah.
streamlined way.
Swing here. So really there's three things they can do. Because you can add a link as part of a way you hand in a classroom.
Oh,
Right, I believe. So like if we went
yeah.
to So one thing they could do is they could just go share, and then you want to make sure that they give you edit, right? Allow editing, and then just copy link.
Okay.
And
Because I had them.
oh, sorry, and you have to say
on their
people
home
with
computer.
the link. People, it's got to say people with the link, and then you can just say copy link, and it's a link, and then they can just put that. So that's the easiest way, I would
So they're
say.
grade 9. So.
But the other thing they can do is they can save it down. Now it'll be online, so it'll be like download as. So I'll actually show you what they would see. Because they're probably, are they working online or are they working on the desktop?
Those are the ones that are having problems, the ones at home.
The online ones, sure. So they would be on like office.tsp.
Oh,
It'd be on PowerPoint. And so like if they were on the online version, so they can do the share thing, that's what I would do, share and give the link. But if that's giving them trouble, the other thing you can do is save it, download as, just download as a PDF.
Okay.
Download as PDF.
And
that way you...
Mine was much more complicated. I was like, Mr. Orlando uses it every day.
When you go back, you should tell Kristen I said hi.
I will definitely. It's so quiet in my room today. I've
Is
got
it? How many do you have?
And Autumn Beauchamp.
And that's
It's
it?
just
Oh
quiet
no.
people.
Oh no.
Thank you.
Oh, Jesus Christ, my little girlfriend. Are we gonna dissect? Are we gonna dissect frogs?
No. Do you want to see what we're going to dissect?
Oh.
It's a little alarming. Do you want to see?
What is it?
I'll show you.
Yeah.
Look at this.
Oh, it smells good in here. Is that your coffee?
It is. I'm excited about my new coffee.
I just receive these on a daily basis.
Yeah.
Yeah, so I always order. Sorry?
What on earth is that?
It's a pig,
Okay.
but we always order them. Look at the size of these bloody things. They're enormous. Usually they're like yay big, those little guys. And they're really big this year. I'm not sure what happened. So I'm a little intimidated by them. Just because they're big. But I think it'll probably make the dissection easier. Because it'll be easier to work with things because they're big. But
Wait, so are we actually dissecting them?
Oh yeah.
That's freaking lit. Don't bully me. My brain is not processing a lot of things right now.
Yeah, and in fact, I'm going to try to do a day on one of my prep days where I can even have the people who are learning from home, if they want, to come in on a day when no one else is here. Like no one else is in this room and actually do it. Because it's a pretty cool opportunity. Nobody has to. If you have a moral objection or you're just squeamish, there's a digital version you can do. But it's a good experience. But nobody has to.
How sharp is anything we have to cut things open with?
Fairly sharp.
Okay.
You can use scissors though.
So no, here's what I'm telling you right now.
Yeah?
Is that it will be to be determined on the day it happens.
Sure, of
depending
course.
on how bad I'm ticking.
Sure. Well,
I'm not trying to stab myself in the face.
the other thing I always try to do is I always encourage people to, if you are a squeamish type or a tickish type or whatever, is just partner up with somebody who's got good steady hands. You know what I mean? And that way you can.
I was fine with
focusing.
I was fine
If that
with
banging
dissecting
starts
the
again,
frog.
Yeah.
I will not.
And it's actually pretty cool, isn't it? Like you really do, you do learn a lot and it's beneficial. And then the frog is a little bit like we are. The pig on the inside is a lot like we are. It's very, very similar. So it's a worthwhile experience. Howdy. All right. So let's talk about our wrinkled and round pea seeds. What would we call the homozygous dominant here? Homozygous means that the two genes are going to be
Capital R.
very good. Yeah, they're going to be the same because homozygous, and dominant means that they're both going to be the same, which in this case means that we're talking about a round plant. Obviously, the homozygous recessive will look like what?
Those trees are.
Yeah, and what will its phenotype be? That's right. Yep. And the heterozygous would be when we have either big R with little r or little r with big R. Those really mean the same thing. And what will the phenotype be of the heterozygote?
Round.
Very good, because roundness is the dominant trait. So even though they have one of each copy, we'd expect to see the round phenotype. Good. Okay, so now, if a heterozygous round-seeded plant is crossed with a homozygous wrinkle-seeded plant, what would we get? Well, first of all, this guy, the heterozygous round, what is the genotype going to be? Heterozygous round. Heterozygous means Good. So what's the genotype got to be?
Big R and little R.
Very good. And the second guy is homozygous wrinkle-seeded. What's its genotype going to be? Very good. Does that make sense? Are we comfortable with that? You guys are doing great, by the way. You guys are so clever. You're doing really well with this. So now, when we go to put this on the Punnett Square, what am I going to put up here? What do I put in these spots? How do I take, say, this parent who has these two genes, and how do I put them into the Punnett Square? Well, we say that a gamete, a sex cell produced by this first parent, is either going to have the big R gene, or it's going to have the small r. It can produce either type of sex cell because it's got both genes to give, or both alleles to give. Does that make sense? Yeah, Mr. Lino, that makes sense. Oh, good. Wow, Michael, your voice got really high pitched there. I know, it's just a thing I've been trying lately. It's good. It's a good look for you. You should stick with that. Okay, and then what about this fella here? Well, it doesn't matter which gene we get here, or which gene we get here, which allele, because both alleles in this case are actually the same. Right? So because it's a homozygous parent, we get the same gene, whichever one they pass on, because both the copies are identical. All right, there we are. So in this crossing then, one of the four possible outcomes is these will meet up. If this egg cell is fertilized by that sperm cell, what do we get here? Very good. And what? No, you really can't, eh? And what kind of seed shape would we get here? Very good. So the genotype would be big R, little r, and the phenotype would be round. What am I going to get if this egg cell is fertilized by that sperm cell? Very good. And in this case, then, we will have a good old little wrinkled seed. What about here? Yep. And what will that's the phenotype. Very good. What will the genotype be? Yeah, very good. And lastly, this guy here. Yeah, and what will the phenotype be? Very good. Does that make sense? Awesome. You guys are great. Really good. And so just, again, for some reason I've got that extra there. Didn't really mean to have an extra there, but here we are. If we look at the possibilities, again, I'm going quickly here because I'm just rewriting these from above. How many were big R in the F1 generation? Of the offspring, how many were big R in this particular crossing?
Big R?
Yep.
None.
Very good. All right, so you can't get big R if these are your parents. Not possible. And obviously 0 out of 4 is what percentage?
0.
Very good. Big R, little r, or little r, big R, how many of these were that? Yep, very good. And 2 out of 4 is what percentage? 50. And obviously that means the other two were homozygous recessive, which is the other 50%. And there we go. And again, that just shouldn't be there. Whoopsie. All right. So that's the concept here. This is a biggie. There's an assignment on the next page, which just has 5 examples and 5 questions. I'm happy to help you if you need it, but work your way through them. There's a page after that, which deals with a weird case, where sometimes something isn't totally dominant. Sometimes you get something else happening. So you'll go through that and learn about that. And that'll be it for today. So you should have time today to finish all that in a perfect world. And that means that then you can get caught up on old stuff or whatever. So I'm going to leave you now. And then Aaron, why don't we do some planning right after the next break? Does that work? Cool. All right.
So are we finishing 3.5 today?
That's right. Work your way through 3.